In this video, we're going to talk about solving systems of linear equations in two variables by graphing. A system of linear equations is a set of two or more equations that must be solved simultaneously. An example of a system of linear equations in two variables is given here. A solution to a system of linear equations in two variables is an ordered pair that is a solution to each equation in the system. So we want to be able to determine if either one of these ordered pairs is a solution to this system of linear equations. So let's start with -2, -1. I'm going to replace x with -2 and y with -1. So let's start with the top equation. So -2, -1 is a solution to the top equation. Now let's check the bottom. -1 does not equal -22, so -2, -1 is not a solution to the second equation, therefore it is not a solution to the system. Now, let's check for -10. So I'll start with the top equation. So we can see 4 -10 is a solution to the top equation. Now let's check the bottom equation. We see that 4 -10 is a solution to the bottom equation. Therefore, we can write 4 -10 is a solution to this system of linear equations. So now I want to start graphing two lines on the same coordinate plane. Well, there are three cases that could occur. You could have intersecting lines, and the solution to that system would be where the two lines are intersecting. They will have different slopes, but the y-intercept may be the same or different. This is a consistent and independent system. You could have two lines that are parallel. Well, because parallel lines do not intersect, you would not have a solution to the system. That means you would have the same slope, but different y-intercepts. And this is what is referred to as an inconsistent system. You could have infinitely many solutions when the two equations graph to be the same line, meaning it would have the same slope and y-intercept. All right, so let's solve the following systems by graphing. Now, the top equation is already in slope-intercept form. So I'm going to write out the slope and the y-intercept, which is -1. And I can write that as an ordered pair 0, -1. That means the slope can either go up and to the right or down and to the left. Notice I have this labeled by 1s. All right, so now let's plot the points. And from there, I'm going to go up 2 and to the right 1. Do that one more time. Or I can go down 2 and to the left 1, and then do it again. Connect the dots. Okay, so now let's take a look at the bottom equation. I'm going to solve this by calculating its x and y intercepts. X-intercept, we know y is 0. We can see that when y is 0, x is 5. I can write that as the ordered pair 5, 0. Y-intercept, x is 0. You can tell very quickly when x is 0, y is 5. So I can write that as an ordered pair. Let's plot these 2 points. And now I'm going to connect the dots. Now, notice where these 2 lines intersect. That is this particular point here. And they intersect at 2, 3. Now, we better check to make sure that 2, 3 is a solution to both. Well, checking the top, we know that 2 times 2 is 4 minus 1, that is 3. And then 2 plus 3 is 5. So 2, 3 is the solution to this system. Okay, let's take a look at the next system. Again, x plus 3y is equal to 3. I'm going to solve by calculating the x and y intercepts. So x-intercept, y is 0. Again, we can tell quickly x is 3. Right as an ordered pair, 3, 0. Y-intercept, that means x is 0. When x is 0, we know y is 3. Okay. Okay, let's plot these 2 points. And now I'm going to connect the dots. Okay, now let's take a look at the bottom equation. So, we know this is going to be a vertical line. But we'll graph by plotting points just to remind us. It does not matter what value of y that I pick. When I plug in any y value, multiply it by 0 is 0. And when I add -1, the x values are always going to be -1 here. So let's plot these. And now let's connect the dots. All right, so now it is drawn. We can notice right here then, at the point -1, 4, is where they intersect. Let's check it. The top equation, -1 plus 4 is 3, and the x-coordinate here is -1, just like it is here. So we can write that -1, 4 is a solution to this system. All right, let's go to the next example then. All right, so I'm going to start with the bottom. Okay. So again, with y equal to 3x minus 2, I know the slope is 3 over 1, meaning it can go up and to the right or down and to the left. The y-intercept is 2, so I can write that as an ordered pair 0, 2. Okay, so let's graph this. So start at 0, 2, and then do my slope. Connect the dots. Okay, so now I want to take the top equation and solve that for y to get into slope-intercept form. Subtract 1. So the slope is 3 over 1, and the y-intercept is -1, and I can write that as an ordered pair 0, -1. So again, the slope up and to the right, or down and to the left. So let's do that. Connect the dots. Now, you can tell very quickly that these two lines are parallel, meaning that there is no solution to this system. Now, even without these horrific graphs that you're looking at, you could look at the slope of the top equation, which is 3, and the slope of the bottom equation, which is 3. But notice the y-intercepts are different. Remember, we talked earlier in the course that if two lines have the same slope but different y-intercepts, then the lines would be parallel. And now we've shown that here. All right, one other example I want to take a look at. Now, before I even graph the top equation, I want to solve the bottom equation for y, or to get into slope-intercept form. So I'm going to subtract the x and divide by -2. Now, notice they are the exact same equation. So we know we're going to have infinitely many solutions, but I'm still going to graph this line on the coordinate plane. So let's start with the y-intercept. And 1/2, that's up 1 to the right 2, or that's going to be down 1 and to the left 2. Connect the dots. And now let's write out the solution to this system. There are infinitely many solutions to this system. Now, I want to make a very important point before we're done with this video. We have infinitely many solutions, but we do not have all real numbers at work here. For instance, I know that 0, 1 is a solution in this system because that ordered pair is part of the line. But 0, 0 is not a solution because 0, 0 is not anywhere on this line. So again, you do have infinitely many solutions, but you don't have all real numbers for this.